Hey guys, welcome back to another video from the Education App Guru. Today we're going to review an app called Stephen Hawking's Snapshots of the Universe. It's a science app. It would be appropriate for upper elementary into middle school and high school. I personally have used it in my 12th grade physics class. So here it is in the App Store. I'm not sure how much Stephen Hawking actually had to do with developing the app, but it does have his name attached to it. It's going to be a series of small games and activities that review physics concepts. I know you can't see the price, but at the time that I made this video, it was $4.99. There's one in-app purchase that they added after an update, 99 cents for a couple extra little activities in the app. So I'm going to go ahead and tap on open here. It's a game sort of app. It's going to present several little experiments and activities that you can go through to learn physics concepts. There's a small introductory video by Stephen Hawking if you choose to open that, but I'm just going to go ahead and swipe. And we're going to go into the first activity here. You can get to the different activities or different games that they have by tapping on the plus button that was in the bottom left-hand corner. And that first S or infinity sort of looking thing is the front page of the app that we were just on. And then down here at the bottom we have all the different little activities. So on this first one, building a solar system, I'm just going to swipe up to get us into the activity. And it'll show us some instructions on what each of the different buttons on the screen do. I'm just going to go ahead and exit out of that. And here we are. We're supposed to build our solar system by dragging planets from the right side of the screen onto the solar system, onto one of these ellipses. And then it says pull to aim. So if I put my finger down on the planet and drag, I'm going to be pulling the planet back, and I'm going to be able to kind of slingshot it into an orbit around this sun. So you want to get your arrows to line up with one of these ellipses. The farther you pull back, the more speed your planet has. And then you move it up and down to adjust the angle. So that looks okay. I'm going to leave it and see if it stays in an orbit. Once the planet figures out that your planet is going to stay in the orbit that you put it in, it lets you try to add another planet. So I'm going to move this one a little bit farther out, pull it back to try to aim it, and let it go. The key, though, is that you don't give your planets too much speed or too little speed. You can see I gave mine a little bit too much speed, and I lost it. It escaped the solar system. So they want me to try again, pull the planet back out, and it probably had too much speed because it's too far away from the sun. It needs to be going a little bit slower. So I'm going to pull it back not quite so far and put it in an orbit, and I can see now it is going to start to orbit around the sun, which is good. Though that's kind of a weird little orbit, so let's hope that it doesn't do something weird with the other planets there. And now, oh goodness, since I've done such a good job with these first two, they want me to add a third planet, put it in there, pull back to release it, to aim it, and release it to let it start its orbit. And now we have 3 planets orbiting around our sun here. So the planets orbit slow when they're farther away from the sun. If they get close to the sun, you can see they move a lot faster around. And it is possible for the planets to run into each other. It looked like I lost that little blue planet, but I think he's still floating around somewhere. So I'm going to try to add one more. Oh goodness. Like I said, if the planets' orbits overlap or you didn't do it quite right, they can run into each other and it would destroy both of those planets. So that's not very good. So that's a pretty fun activity to play around with. Some of the other activities I like to use in my physics class because they help us practice concepts with the theory of relativity, Einstein's theory of relativity, that are hard to demonstrate in the class. You know, you can go through a sort of thought experiment, a story with the kids, but this little activity is really helpful. So this is it's called the twin paradox. The idea is that if an object or a person, any living organism travels very, very fast, the rate of time is going to pass differently for them than it does for their twin who would stay on the Earth. So we put one of the twins in the spaceship and adjust how fast our rocket is going to go. Let's say 85% the speed of light. Launch your spaceship and it's going to take a little voyage to a star and then come back to the Earth. And it's going to show us the twin that stayed on the Earth. His age is 51 years now. And the twin that went in the spaceship is only 27 years old. So the rate of time that passed for the twin in the spaceship was only about half of the rate of the time that passed for the people back on the Earth. So again, I know that's a weird concept, but it's something that we go over in the theory of relativity, and this is a nice way to visualize it. I'll show you one more activity called the relativity of motion, which is not really to do with Einstein's theory. It's an older theory of relativity. The idea is that the way that we measure motion is relative to your reference point. So we have to decide how fast this guy is walking. Is he walking 3 miles per hour or 63 miles per hour? For this first one, you choose the answer that you think is correct and tap on it, and it actually doesn't matter which one you choose. They're going to tell you that you're both right and wrong because he's moving 3 miles per hour relative to the train, but 63 miles per hour relative to the ground. And we kind of got a clue from that based on how fast the trees were passing. If I tap on continue up at the top, now we're starting the activity. It's going to have us adjust. It has us start off by choosing which of the two people, the girl on the bottom or the guy on the top, is moving faster relative to the ground. So the guy's running at 9 miles per hour, but his train's only going 2 miles per hour. The girl is walking very slowly, but her train's going faster, so she's probably the one that's moving faster, which is correct. And then later it has you adjust their speeds so that they're moving the same speed relative to the ground. So again, that's a pretty fun little app for learning how motion is relative to your reference point. There's several different activities down here. Again, I find it is worth the money for my physics class, and even for younger grades, I think it would be a pretty cool little game to play in class with your kids. Alright, that's going to do it for this app review of Stephen Hawking's Snapshots of the Universe. You can find more video app reviews and also video tutorials on my website, edappguru.com. Thanks for watching.